So now we want, for example, if we want to bring the energy use intensity, which is the total or annual energy consumed by a building per unit area, you can bring this first. You can separate data so that you could have the numbers alone and the strings alone. And here I brought the numbers, and I'm going to bring a component which is called Honeybee normalized data by floor area. You hook up the results in the simulation data, and the Honeybee zones from the materials, the last one, which is the materials, you hook it up here, and then you can find you can have the normalized data for the energy use intensity, which is reflect the energy use, annual energy used per unit area. So here now we can go to we can use this as they can show this panel. Here you have the total number of energy used. You can bring a number and rename this number thermal load, maybe total thermal load. And then you have one of the objectives. Now we will go to Octopus. And here is the objectives. So I will go, you can start by press shift if you want to use more than one objective. So here we have the objectives, and now we have the values for different dynamic parameters. As we stated here, for dynamic parameter, I'm going to hook up by using shift to hook up more than one value for the dynamic parameters. And we have also the windows, as we have stated, are going to be used as dynamic parameters. We have also the shading devices for the north, for the south elevation, which is going to be manipulated during the experiment. And now I will remove this old Octopus component so as not to be confused. And now here, before starting the optimization, I want to show you how to use the TT-toolBOX. The TT-toolBOX is used to record the dynamic parameters, the values of the dynamic parameters with their corresponding value of the objective functions during the experiment. It's very important to use it because Octopus doesn't show the number of the values of the dynamic parameters. It does only show the values of the objective functions, but you will not be able to bring the values of the dynamic parameters from Octopus after finishing the optimization. And here we don't have a lot of dynamic parameters, so I don't need all these components. It's a component which is called Calibri parameters. You can find it in the TT-toolBOX, and you can download the TT-toolBOX from Rhino or Grasshopper. There's the websites. So here, in the previous experiment, because I had a much complicated model and a lot of values for the dynamic parameters, I needed more than one component because TT-toolBOX causes errors with a component that has many values. So I had to divide them up into different lists. So here, let's take these values of dynamic parameters. We may also change, you may bring a new one, which is Calibri parameters. And we can remove this. We have here only 3 values. And we have here, and also the number of, the name of the slider counts in the idea of making errors if we have too many data. So it's better that I simplify the name of, for example, X. This is going to be better to have X instead of have data 3. It's better to have sliders with simplified names. So here I might say S for shading devices and hook it up here. And I might also change these to maybe F1, which is the form, F2, and F3. And hook them up again so that I could simplify the names and have minimize the number of letters and values in general in this Colibri component. And now I will hook up the result of, which is the total thermal load. So we have here the parameters. I will go up here to this component, which is called Colibri aggregator. I will remove these components because I no longer need them. I will add this to the group and we'll choose here to put this as the genome, and here it needs a phenom parameter. So I will remove the thermal load and take this again and go here to take parameters. I will take the total value. We need the total value, not the energy use intensity. So I will take this total value, remove this one. So we have here, again, I need this one instead, but no problem. It's going to be the same value actually. It's not necessary to take this one. So it's R is enough. I'm going to remove data 2 and go back here and hook up the phenom so as not to get any errors. Now add to group, and here you choose the value, the folder where you want to put, let's say that YouTube, for example. Okay, now you can see that in the C folder, here in the C, you will find something that is called YouTube. Once you hit true, so here you will find in the C the YouTube file, which will contain an Excel sheet with the extension .csv that will contain your data. So if you click on this sheet, you will find that you have the F1 as we have stated before, F1, F2, F3. You can then know the different values by knowing that they have different names. XS and the out is R. Image is the image in the Rhino that is going to be also saved during the experiment for each dynamic parameter, but you don't have, you will not be able to use it because you need to work on providing a good rendering in these images generated or saved by the TT-toolBOX. So now I will save my files. You need to do it actually from time to time, because sometimes you might lose the electricity or something that you don't, and then you will not find your data available. So here in Octopus, I want also to mention that Octopus is better than using the other optimizer that was an old one, just called, I don't remember its name now, because Octopus does save your data. So if you're going to perform the optimization and then close the Grasshopper and Rhino and then open it again, you will find your data still available inside the component by right-click here. I will reset because it doesn't have anything. But here we have just one component, one objective function, and we want to use what is called single objective optimization, while in this case, in order to be able to do single objective optimization in Octopus, you will need to assign a diversity parameter as a second objective, because it doesn't run single objective optimization on its own. So here we have chosen to add the diversity parameters. So you will find here total thermal load, which we have hooked up before in the objectives. And here you can control what you want to do here. You can control some parameters inside Octopus. The maximum generation, for example, let's assume we don't want to have more than two generations, where you can control this here. Here we have different, I will show you this after performing the optimization. So I will start. It's going to take some time, so I will leave you and come back again after finishing a considerable number of configuration of simulated configurations.